This is lesson 8.4, Trigonometry. Your objectives are to find trigonometric ratios using right triangles and to use trigonometric ratios to find angle measures in right triangles. The ratio of the lengths of two sides of a right triangle is called a trigonometric ratio. The three most common ratios are sine, cosine, and tangent, which have the given abbreviations. Each of these has a formula. Sine of the angle equals the opposite leg over the hypotenuse. Cosine of the angle equals the adjacent leg over the hypotenuse. And tangent of the angle equals the opposite leg over the adjacent leg. Keep in mind, with trigonometry, you will be asked a lot of different types of questions. So you need to make sure you know what you're being asked and that your answer fits the format of what you're being asked. Sometimes you're asked for a side length. Sometimes you're asked for an angle measure. And sometimes you're simply asked for the ratio. So your answer could be a fraction using the side lengths that they give you. Always answer the question being asked. So in this triangle, I have right angle T, and I'm taking my trigonometric ratios with respect to angle R. Now I need to identify the opposite leg, the adjacent leg, and the hypotenuse. The opposite leg is the side that's opposite angle R. If I draw across the triangle, then that side is the opposite side. If I draw across from the right angle, that side is the hypotenuse. And the leg that's next to angle R is the adjacent leg. So always start by identifying the side lengths of the triangle as opposite, adjacent, and hypotenuse. The formulas for sine, cosine, and tangent can be remembered very easily using this shortcut. SOH, CAH, TOA. SOHCAHTOA. SOH stands for sine is opposite over hypotenuse, which in this figure, the opposite is length R, and the hypotenuse is length T. CA stands for cosine equals adjacent over hypotenuse. In this figure, the adjacent is S, and the hypotenuse is T. S over T. TOA stands for tangent equals opposite over adjacent. In this figure, opposite is R and adjacent is S, R over S. SOHCAHTOA. It's a very easy way to remember the three formulas. Find sine J, cosine J, and tangent J, sine L, cosine L, and tangent L. Give your answers as fractions and as decimals. Here we're looking for the trigonometric ratio, so our answer will be a fraction and a decimal. Start with angle J. When I use angle J, let's identify opposite, adjacent, and hypotenuse. The side opposite angle J is opposite. The side opposite the right angle is the hypotenuse. And the leg that's adjacent to angle J is adjacent. Start with sine. Sine of J equals opposite over hypotenuse. Opposite is 12, and the hypotenuse is 20. That reduces to 3/5, and as a decimal, that's 0.6. Cosine of J equals adjacent over hypotenuse. Adjacent is 16, hypotenuse is 20. That reduces to 4/5, which is 0.8. Tangent of J equals opposite over adjacent. Opposite is 12, adjacent is 16, which reduces to 3/4, and as a decimal, it's 0.75. Now let's do the same thing for angle L. I'm going to have to re-identify my sides. With angle L, the side across from that angle is opposite. Before, 12 was opposite, but that was opposite angle J. Now 16 is opposite, which is opposite angle L, which is what I'm using now. The side across from the right angle is the hypotenuse, and the leg next to angle L is adjacent. Now let's find sine, cosine, and tangent using the formulas they give you. Sine of L equals opposite over hypotenuse. Opposite is 16, the hypotenuse is 20, which reduces to 4/5, and as a decimal, that's 0.8. Cosine of L is adjacent over hypotenuse. Adjacent is 12, hypotenuse is 20. That reduces to 3/5, which as a decimal is 0.6. Tangent of L equals opposite over adjacent. Opposite is 16. Adjacent is 12. That reduces to 4/3, and as a decimal, that's about 1.33. So use your sine, cosine, and tangent formulas and substitute in the side lengths for opposite, adjacent, and hypotenuse. You can use a calculator and the sine, cosine, or tangent to find the measure of an angle, called the inverse of the trigonometric ratio. When you use a calculator, make sure that your calculator is in degrees, not radians. On a TI-83 calculator, push the mode button and make sure that degrees is highlighted instead of radians. If radians is highlighted, then go down and make sure that you switch to degrees. Otherwise, your answers won't be right. Find each angle measured to the nearest degree. Number 2. Sine of A equals 0.5150. Here we're looking for the angle measure, so our answer will be in degrees. I'm solving for the angle, which is A. With the A, I have sine. I want to get rid of sine, so A is by itself. So I have to do the opposite operation of sine. The opposite operation of sine is arc sine. So I need to take the arc sine. That is sine with the -1 on it. To get to that, push the second button and then the sine button, which has sine -1 above it. That's the arc sine. And I'll take that of 0.5150. When I punch that in, A is approximately 31 degrees. Number 4. cosine W equals 0.6157. I need to do the opposite of cosine, which is arc cosine. So W equals cosine -1. So I hit second and the cosine button of 0.6157. And that's approximately 52 degrees. Remember, when you're looking for the angle measure, do the inverse function, the arc sine, the arc cosine, or the arc tangent. The inverse gives you the angle measure. Number 6. Tangent of W equals 19.0811. To solve for W, do the opposite of tangent, which is arc tangent. Hit the second and then tangent button. Arc tangent of 19.0811, and that gives you approximately 87 degrees. Use a calculator to find the measure of angle T to the nearest tenth. Now we're working in a triangle. To find the measure of angle T, I need to identify what sides are opposite, adjacent, or hypotenuse. The side across from angle T is opposite. The leg next to angle T is adjacent. Now, should I use sine, cosine, or tangent to answer this question? Remember SOHCAHTOA. Since I'm using opposite and adjacent, that's TOA, tangent. Tangent of theta equals opposite over adjacent. Theta is a Greek letter that is used often for angle measures in trigonometry. So we're going to use tangent. Substitute in. Tangent of theta, which is t, equals opposite 14 square root of 3 over adjacent 34. Since I'm looking for angle T, I'm going to do the arc tangent. T equals the arc tangent of 14 square root of 3 over 34. When you punch that in your calculator, T is approximately 35.5 degrees. Be careful with your parentheses on the calculator. Make sure everything is punched in correctly. And since we're looking for an angle, our answer will be in degrees. Number 2. Again, solving for the measure of angle T. Identify the sides. The side across from angle T is opposite. The side across from the right angle is hypotenuse. So should I use sine, cosine, or tangent? Remember SOHCAHTOA. Since I'm using opposite and hypotenuse, SOH. That's the one I'll use. Sine of theta equals opposite over hypotenuse. I'm using sine because my sides that I'm using are opposite and hypotenuse. Now substitute in. Theta is t, opposite is 7, and hypotenuse is 18. To solve for t, do the opposite of sine, which is the arc sine. The arc sine of 7/18. And when you punch that in your calculator, you get approximately 22.9 degrees. Make sure you're in degrees and not radians in your calculator, and punch everything in carefully. Remember, when you're working with a triangle, identify the sides you're using, opposite, adjacent, or hypotenuse. Determine which trig function to use, sine, cosine, or tangent, and then substitute the values into the formula and solve for what you're looking for. Again, we're looking for angle T here. Let's identify the sides we have. The side across from the right angle is the hypotenuse. The leg next to angle T is adjacent. Should I use sine, cosine, or tangent? Remember SOHCAHTOA. Since I have the hypotenuse and the adjacent, I'm going to use cosine, C-A-H, because the cosine of theta equals adjacent over hypotenuse. I chose cosine because the sides I know are the adjacent and the hypotenuse. Substitute in. The angle is T, adjacent is 34, and hypotenuse is 87. To find T, do the opposite of cosine, which is arc cosine of 34 over 87. And when you punch that in the calculator, you get approximately 67.0 degrees. I'm using adjacent and hypotenuse, so I use the cosine formula. Find the missing side. Round to the nearest tenth. We have a similar situation here because we're looking for a value in a triangle. Now, though, it's a side length instead of an angle measure, but everything is worked out pretty much the same way. You identify the sides as opposite, adjacent, or hypotenuse with respect to the acute angle you're working with. Decide whether to use sine, cosine, or tangent, and then substitute in and solve. Let's identify the sides. The angle I'm working with is the 72-degree angle. The side across from the right angle is the hypotenuse, and the leg next to the angle I'm working with is adjacent. Which trig function is it? Remember SOHCAHTOA. Since I'm using hypotenuse and adjacent, I'll use cosine. Cosine of theta equals adjacent over hypotenuse. Now substitute in. Theta is 78 degrees. Adjacent is 6, and the hypotenuse is x. Here, my variable is in the denominator. There's actually a very quick way to deal with this. Consider the situation where 3 equals 6 divided by 2. If I switch places with the 3 and the 2, 2 equals 6 divided by 3. It makes sense. Those are both true. So whenever your variable is in the denominator, you can switch it with whatever's on the opposite side of the equal sign. So I'm going to switch x with cosine of 78 degrees. Now x is on the left, and cosine of 78 degrees is my denominator. When I put that in my calculator, it's approximately 28.9. That's a side length. It's not an angle measure, so it doesn't get degrees. It's a side length. Number 3. I'm looking for side length x. Identify opposite, adjacent, and hypotenuse. The side opposite my angle that I'm working with is the opposite side. The leg next to the angle is adjacent. Always determine the opposite, adjacent, and hypotenuse based on the acute angle you're working with. Now, do I use sine, cosine, or tangent? Remember SOHCAHTOA. Opposite and adjacent, OA, that'll be tangent. Tangent theta equals opposite over adjacent. Substitute in. Theta is 24 degrees, opposite is x, and adjacent is 12. Solve for x. Since that's x divided by 12, do the opposite and multiply both sides by 12. On the left, that gives you 12 times the tangent of 24 degrees, and on the right, the 12s cancel out, leaving x. When you punch that in your calculator, x is approximately 5.3. That's a side length. Always make sense out of your answers. If one of those sides is 12, and the side I'm looking for, which is definitely shorter than the other side, is 5.3 a logical answer? Yes, it is. Number 5. In working with this triangle, let's first identify the sides I'm dealing with. With respect to the acute angle that's measured 49 degrees, the side across from that is opposite. The leg next to it is adjacent. Do I do sine, cosine, or tangent? Remember SOHCAHTOA. Opposite and adjacent, OA, that'll be tangent. Tangent theta equals opposite over adjacent. Identify what the sides are, and then determine which trig function to use. Substitute in. Theta is 49 degrees, equals opposite, which is 14, over adjacent, which is x. When x is in the denominator, remember you can switch it with what's on the other side of the equal sign. So x equals 14 over tangent 49 degrees. When you punch that in, x is approximately 12.2. Is that a logical answer? One side is 14. Another side that's a little bit shorter than that is 12.2 logical? Sure it is. Identify opposite, adjacent, and hypotenuse. Determine whether to use sine, cosine, or tangent. Substitute in and solve. This is lesson 8.5, Angles of Elevation and Depression. Your objectives are to solve problems involving angles of elevation and depression, and use angles of elevation and depression to find the distance between two objects. Angles of elevation and depression. Many real-world problems that involve looking up to an object can be described in terms of an angle of elevation, which is the angle between an observer's line of sight and a horizontal line. The angle of elevation starts horizontal and then goes upward. When an observer is looking down, the angle of depression is the angle between the observer's line of sight and a horizontal line. The angle of depression starts when you're looking horizontal and then tipped down. When you do story problems that involve angles of elevation or angles of depression, consider the right triangles formed. One measure will be a horizontal measure, another will be vertical, and another will be diagonal. When you put those three together, you get a right triangle. Where the horizontal and vertical sides meet is your right angle. Another thing to consider, with the angle of depression, we have two parallel lines cut by a transversal, and alternate interior angles are congruent. So if you consider the angle of depression, which starts horizontal and looks down, is congruent to an angle of elevation that would start horizontal and look up. So an angle of elevation is always the same as the angle of depression. Keep that in mind because sometimes the angle of depression is outside of a triangle, and you need to get an angle that's inside the triangle. So you can always make it congruent to the angle of elevation to get the angle inside the triangle. Problems involving angle of elevation and angle of depression, since we have right triangles and we're dealing with side lengths and angle measures, we're going to use trigonometry. Number 1. The angle of elevation from point A to the top of a hill is 49 degrees. If point A is 400 feet from the base of the hill, how high is the hill? We'll consider the right triangle. The angle of elevation is going to be the angle that's at the bottom. 400 feet is a horizontal because it goes from that point to the base of the hill. How high is the hill? Height is vertical, so that'll be the vertical side. Identify your sides, opposite, adjacent, and hypotenuse. The side across from my acute angle is opposite. The leg next to it is adjacent. Will I use sine, cosine, or tangent? SOHCAHTOA. If I'm dealing with opposite and adjacent, that's going to be tangent. Tangent theta equals opposite over adjacent. Substitute in. Theta is 49 degrees, opposite is x, and adjacent is 400. That's x divided by 400, so let's multiply both sides by 400 to get the x by itself. So 400 times tangent 49 equals x. When you punch that in, x is approximately 460.1 feet. Is that a logical answer? One side is 400 feet, and that side is very close to it in length. 460.1 is a logical answer. Number 2. Find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. Well, I'm looking for the angle of elevation. The telephone pole is vertical, that's my 12.5. The shadow is on the ground, so it's horizontal. So consider those in your triangle. Now identify the sides. The side across from our angle is opposite. The leg next to it's adjacent. Will I use sine, cosine, or tangent? Remember SOHCAHTOA. Adjacent and opposite, use tangent. Tangent theta equals opposite over adjacent. Substitute in. Theta is what I'm looking for, so that'll be my x. Opposite is 12.5, and adjacent is 18. Since I'm looking for the angle measure here, I've got to get rid of tangent. So do the inverse function. X equals arctangent of the fraction 12.5 over 18. When you're looking for the angle, always do the inverse of the function. When you punch that in, x is approximately 34.8 degrees. Is that a logical answer? Sure, that could be a 34.8 degree angle. Identify the sides. Determine which trig function to use. Substitute in and solve. Number 3. A ski run is 1,000 yards long with a vertical drop of 208 yards. Find the angle of depression from the top of the ski run to the bottom. Well, remember, the angle of depression is congruent to the angle of elevation, and that will give us an angle inside the triangle. Identify the sides as opposite, adjacent, or hypotenuse. The side across from our angle is opposite. The side across from the right angle is the hypotenuse. So will I use sine, cosine, or tangent? Since I have opposite and hypotenuse, I'll use sine. Sine of theta equals opposite over hypotenuse. Substitute in. My angle is x, opposite is 208, and hypotenuse is 1,000. Since I'm looking for the angle, do the inverse function. X equals the arc sine of 208 over 1,000. When you punch that in, you get approximately 12.0 degrees. Is that a logical answer? Sure, that's a very narrow angle. 12 degrees would work. Number 4. From the top of a 120-foot high tower, an air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. How far from the base of the tower is the airplane? Well, the tower is vertical. The distance from the base of the tower to the airplane is horizontal. And I have an angle of depression, which is congruent to the angle of elevation. So I can get inside the triangle by moving to the angle of elevation. Identify the sides. The side across from our acute angle is the opposite side, and the leg next to the angle is adjacent. Do I use sine, cosine, or tangent? Since I have opposite and adjacent, I'll use tangent. Tangent theta equals opposite over adjacent. Substitute in. Theta is 19 degrees. Opposite is 120. And the adjacent is x. Since x is in the denominator, switch it with the opposite side. X equals 120 divided by tangent 19 degrees. When you punch that in, x is approximately 348.5 feet. Is that a logical answer? Well, in this triangle, one side is 120. That's a small angle, so that means that the adjacent side would have to be a lot longer than 120 feet, and 348.5 feet makes sense.